Okay. So we are going to, in this video, we are talking about how to solve the equation tan x equal to c such that c is a real number. So it's not like, so we know that the function tan x is defined over, so let's say, right? So tan x is defined when x is different of pi over 2 plus k pi such that k belongs to z. Sine and cos are different over r. So this is the first thing to keep in mind. So the images, so the image, let's say this is my set D. So the image of D by the tan function is r. What does this mean? It means that the equation tan x equal to c has solution in r, in over D. So whatever c, it means here, whatever c belongs to r, the equation tan x equal to c has solutions in D. Okay. So in the set of definition of the tan function. So this is the first thing. Okay. Okay. Now it's either we solve the equation in R or we solve it in some interval. Okay. So if we solve in R, so we have to find first an alpha such that tan alpha equal to C. Then we apply the property, which is this one here, given here. Then we just give our conclusion. Okay. So for example, if I want to solve the equation tan x equal to 2 in R, so the value 2, we don't know a special value alpha such that tan alpha equal to 2. Okay. It's not like the number 1 or 0 or split of 3 or split of 3 over 3, right? These are special values. The number 2 is not special value for us, for the function tan. So since we don't know what is it, so it's either we use the calculator to give us an approximation of alpha. So the calculator will never give us the value of alpha, but instead there's some approximation of alpha, and the calculator would always give us a value which is between negative pi over 2 and pi over 2. We have to be careful to that. This is one option. The second option is to use or to get a good approximation using the unit circle and the protractor. So we are going to discuss this when we see the second, we're solving some interval. We'll talk back again about this. So to do the job, I don't need to give an approximation actually. I just need to define what is it in this case, because alpha is not some special value. So I have tan alpha equal to 2, and I know that tan alpha is sin alpha over cos alpha. Since sin alpha over cos alpha is more than 2, this means that sin alpha and cos alpha both have the same sign. So for the sine and cosine to have the same sign, we should be in this quadrant or in this quadrant in the unit circle. Okay, so it means that it's either between 0 pi over 2 or let's say it's between negative pi and negative pi over 2. Okay, it's just a matter of choice what values we can choose for each of these 4 points. Okay, so since I'm having tan alpha is positive, I'm going to pick alpha is somewhere between 0 and pi over 2. Let's say I know that tan of pi over 4 is somewhere here, right? This is corresponding point. It's equal to 1. I know that the limit of tan x, when x goes to, I don't know, I know, never mind. I know that tan of pi over 3 is equal to square root of 3, right? So pi over 3 is somewhere here. Okay, this is in half. Okay. So tan alpha, the tan function is strictly increasing. There's some properties of the tan function. The tan function is strictly increasing over 0 pi over 2. So tan alpha equal to, okay, which is more than square root of 3, which is equal to tan of pi over 3. Thus, I can conclude that alpha is more than pi over 3. So it means that my alpha, the point corresponding to it, should be somewhere here. So I don't know what is the real location of it, but at least I can have a range for my alpha. So in general, we are not going to do this job. We are just going to state that alpha is between 0 and pi over 2, like I did state here. Okay. We would not care much about what is the exact position of the point. But if you have this in mind, you can compare your alpha with some special number to help you to point, okay, the location of alpha. Then once I have that, I can just solve the equation and I get my solutions. So here, thus, the set of solutions is S0, which is this one, alpha plus k pi such that k belongs to 0. So this is how we solve such equation in R. So I don't have to write all this actually. I mean, finding the range for alpha, this one, alpha to pi over 2. You can do it mentally. So the most important thing to state is to say that alpha is in this interval, okay? Satisfy this condition, and it is in this interval. Okay. Okay. And you give the final conclusion after solving your equation. So this is how to solve in R. Okay. Now if you try to solve in a given interval, so the best way is to use the unit circle. Otherwise, if we solve in R, then we try to do the intersection with our given interval. May take some time depending on the interval or the set we are solving in. So using the unit circle, we have few steps to follow. They are listed here, right? I'm going to show them for the same example. Okay, so the first step is to draw the unit circle. So we draw the unit circle. We'll just redo the steps on the side here. So my circle is not that nice at all. I'm just going to use the tool here to draw some nice circle. Okay, this looks nice. Okay, I cannot move it. Same problem. Okay, never mind. So this is my unit circle. Okay, and I draw my axis here, right? My hands are not solid today. This looks better. Okay. So once we do that, we go and draw the line of equation x equal to 1. This is the first thing we do. Okay, draw the line of equation x equal to 1. Then we go on this line here and we try to find, so this is 1 here, this is 2. We're trying to find the point that belongs to this line, call it the point H, for height, H. This point, the coordinates of it are, 1, 2. Okay. So So this is my point O, this is my point I. Okay. Then we draw the line OH, is the line that goes through the point O and the point H. So we draw our line. So my drawing is not that nice, actually. Never mind, just explain the idea. Okay. So you can see that. So these are the point of intersection between the line OH and so this is the line OH between brackets like this. It's the line OH, and these are the points of intersection. So this is the first point with the point A. This is the second point with the point B. Okay. So a video also with this point, I don't have an exact video. Unknown one, I will just call it alpha. So I know that my alpha is somewhere. Alpha belongs to 0 pi over 2. Okay. So I can compare. So if I have a nice drawing like this one here, I can see that this is pi over 3 here, and alpha is somehow a bit, just a bit bigger there. Okay, because this is half here. I know that the cos of pi over 3 to half. So alpha is somewhere just next to pi over 3. The video of it, I mean, just slightly bigger than pi over 3. After doing this, I look at my interval I'm doing the job at. So I'm doing the job in the interval from 0 to pi over 3. So 0, the point associated with 0 is this one here. Okay. Point associated with 0 is this. And this is the point associated with 3 pi. So to know how many laps we are going to do, okay, so here, step 6 here. So I have alpha, and I have here the video beta, right? So beta is actually alpha plus pi. So we don't need beta to do the job, actually. So then I go and see, do the difference between b minus a, which is 3 pi. I have b minus a in my example is 3 pi minus 0, which is to 3 pi. And this is 2 pi plus pi. It means that I would do 1 lap and a half. Okay. Then to read my solutions in a given interval, which is from 0 to 3 pi, I would just go and start working my interval around the unit circle and do the reading. So I start from 0, I move alpha distance. So the first solution is alpha. I carry on, I reach pi, and this is beta. So this is alpha plus pi. Okay. Then I go back to the same point. This is 2 pi now. Then this is 2 pi plus alpha. Okay. So then I carry on. I reach this point. Then this is the value now is 3 pi. Okay. Then I should stop. I'm going to stop. I'm done. I define the solutions in my interval. So this is how easy it is to solve. So the most important thing, do not make it a big deal what is alpha. You can, let's say here, I can use my protractor, take my protractor, get some measurement of this angle. Let's say this is 67 degrees maybe, right? So what is alpha in radian? Remember, alpha is always given in radian. Alpha is going to be 67 times pi over 180 radian. Okay, so, okay, this is a measure of the angle here. So alpha for us is a real number. So we are just going to say that the value of alpha is roughly 67 pi over 180. That's all. So this is just some good approximation of alpha. The calculator will just give you some value which is close to this one if you want to compare. And what is required actually when you do the job is just to draw the unit circle, do all the steps. Okay, especially talk about your alpha, just to give the range for it, because we need this range to understand the solution that we are given. Okay. Okay. Once you have done that, you just give all your solutions using alpha. So actually, alpha is not that known. We have roughly an estimation of it, as well as pi. So there is no difference actually. Pi, we don't know what is it. We don't know what is it. We know an approximation of it. Okay, and we're still working with it. Same story with alpha. We don't know what is the exact value of it. We have an approximation of it, but we still can make use of it or use it in our answer. Okay, so that's all from me for this video. Thank you for watching.